I'm here today to talk to you about the open source project called OpenTelemetry and how you can take advantage of it, the components it consists of, and even kind of show you a demo live of the project. But most importantly, why you should care. First, just a quick introduction. So my name is Steve Flanders. I'm a Senior Director of Engineering at Splunk. I've actually been involved with both the Open Census and the OpenTelemetry open source project since the very beginning. I've been in the monitoring and observability space for over a decade now, working on logs, distributed tracing, and metrics, and really passionate about kind of the open source work that is happening in this space. I'm really excited to be here today to talk to you more about it. If you're interested in learning more about me or other talks that I've done on OpenTelemetry, feel free to follow me on Twitter. All right, so what is OpenTelemetry? Now, I just pulled this directly from OpenTelemetry.io, which is the website for the project. Basically, the way to think of it is a way to instrument your applications and generate, collect, process, and emit telemetry data in an open source and, more importantly, vendor agnostic way. So you may already have instrumentation in your app, but if you want to change it, maybe you're using a vendor's solution, you likely need to change your instrumentation as well. OpenTelemetry is trying to change this behavior, basically a single way that you can instrument and collect data. And then through configuration, you decide how to handle that data, how to process it, and where to send it. Now, it's completely open source and vendor agnostic. It's part of the CNCF, or Cloud Native Compute Foundation, which is part of the Linux Foundation. What that means is that there is no vendor or end user that controls this project. And that's really nice because it's actually an extensible framework that can be leveraged. It actually supports a bunch of open source standards, like, for example, Prometheus or Jaeger. We'll talk more about those in a minute, as well as commercial vendors as well. So there's kind of flexibility and choice depending on your use cases and your business requirements. What I'd like to do is actually break it down into its individual components, and then I'll try to show you some of the value that these components are bringing as part of the project. But what you should note is this is basically everything that you deploy within your environment. Think in your application or like the data collection or agents that you deploy. OpenTelemetry does not actually provide a backend. Instead, it plugs into a variety of different open source and commercially available backends instead. So that's kind of where the project draws the line today. All right, let's go ahead and drill into the different components. Before I do that, I guess just first and foremost, OpenTelemetry is a very active project. It's actually the second most active project in CNCF behind only Kubernetes. This data is actually available on something called DevStats that the CNCF publishes. So you can go ahead and take a look at that. Also worth noting that basically everyone is contributing to and adopting this project. So all major cloud providers are active and involved today. Every major vendor you can think of, whether it's open source or commercial, is involved in some way, shape, or form. There's a lot of end users that not only are they adopting, they're actually contributing to OpenTelemetry. I call that a few of them here on this slide. And then more importantly, you're seeing more integrations with other open source libraries or open source frameworks, for example, Spring or OpenMetrics or even FluentBit. So really exciting to see that there's so much collaboration and so much involvement in this project. And I think it really speaks to like the pain point that people have experienced as a result of either reinventing the wheel by creating their own instrumentation or just supporting it at scale as use cases kind of evolve. So really, really cool project overall. All right, now let's actually talk about the different components. So there's three primary components to the project. The foundational piece is what's called the specification. This is where you're going to find definitions for things like the protocol, the APIs that are used, the SDKs that are used. There are things called semantic conventions. It's basically the framework from which everything else is built on. Now, this framework is a complete open standard, so you're welcome to adopt it. And it actually looks at other open standards and makes sure that it can be compatible. So for example, it works with the Open Census and Open Tracing projects, which were the precursors to OpenTelemetry. It also supports open standards like Prometheus and Jaeger, like I was talking about earlier. So really, it's a superset of open standards that are out there today. Again, kind of giving you flexibility and choice. Now, on top of that are actually reference implementations of the specification. And there's two basic types of implementations. There's what are called instrumentation libraries. These actually go into your application and they are language specific. So all major languages are supported: Java, JavaScript, Node, Go, Python. We'll talk more about that in just a little bit. But the way to think of it is it's a single instrumentation library that you add, and you should be able to emit and collect and generate all the telemetry data that you care about. The other reference implementation is called the collector. Think of it as an agent that sits in your environment. This could be a binary with your application. It could be a sidecar or a daemon set, depending on your deployment methods. It could be a gateway or a network service that kind of aggregates data in a subset of your environment. But the collector's goal is really to receive, process, and emit telemetry data based on the configuration that you define. Now, next, let me drill into each of these different components and why you might care. First, the specification. Given that the specification is kind of an open standard, it's a little bit hard to talk about all the different aspects of it, but I thought I might be able to provide you a couple quick examples of why it matters. First, let's talk about semantic conventions. So OpenTelemetry has this notion of semantic conventions, which are, you can think of it like metadata, key value pairs that are added to the telemetry data that you're generating. Now, what it looks to do is actually standardize how we identify objects within our environment. Good examples of this would be like REST or HTTP calls, could be databases, could be functions. But basically, if you use OpenTelemetry instrumentation and data collection, it's guaranteed to follow this standard across the board. Well, why does this matter? Why would you want to have a standard for these objects for data that you're generating? You can build some pretty powerful features on top of it. Let me give you a very concrete example. Let's say you're running a Java service and you've instrumented it and it's generating telemetry data. And that Java service happens to be talking to a cloud provider's database instance. Now, you probably can't instrument the cloud provider's database instance because you don't control it. The cloud provider is running it on your behalf. But you are very much interested in the data that that database is generating, and you want to understand the availability and the performance characteristics of that endpoint that you're calling. Well, if you're using semantic conventions, you can actually get visibility into that service, even though you're not able to actually instrument it itself. Basically, when your application calls that database, it can call it in a standard way, and all the calls that it's making and any other services that you control that call that same external entity will also be able to generate availability and performance data. Now, there could be other applications that you don't control that are also calling that database, so it's not like full visibility in, but it's this additional step where I can actually see, like, maybe I have a service map of all my instrumented apps. I can also see the services that are being inferred or being called, and they can be visualized in my service map as well, which help me identify if there are problems or hotspots or availability issues that I need to be concerned about. So this is very powerful, and this will work with any backend that supports the OpenTelemetry standard. So as long as your backend does, you're all set. One other quick example is the notion of resources in OpenTelemetry. You should think of resources as like where in the environment your applications are running. So this could be, for example, in Kubernetes, on a pod, on a host, but it could also be like within a cloud provider, maybe running in an AWS region on an EC2 instance. Being able to tack on this resource information with all the telemetry data that you're generating, again, helps you do availability and performance observability of your systems. For example, I can do problem isolation and determine that maybe all of the errors that are being generated for a given instance are happening on a single pod, as shown in the example below, where you have the currency service showing a whole bunch of red, but no purple, where the regions in the cluster name have both red and purple. So I now know that this particular pod name is generating 100% of the errors, isolating the problem and helping me get to resolution a lot faster. All of this information can be tacked on either within your app, but it's pretty common that your application doesn't actually know where it's running. It doesn't have access to the infrastructure information. So OpenTelemetry can actually provide this as part of the data collection mechanisms as well. Basically, all telemetry data that's sent to the collector can be enriched with resource information before it's emitted, again, helping you get better observability of your systems. Now, there are other aspects of the specification that I can't drill into all of them right now, but probably the most important takeaway here is that if you use the OpenTelemetry Open Standard, you have data portability. It now no longer matters which backend or backends you're sending the data to. It's now fully portable because you're following an open standard. Next, I want to quickly talk about the instrumentation libraries. Remember, this is a reference architecture or implementation based on the specification. As I mentioned, all major languages are supported today. And the way that OpenTelemetry handles this is through what it calls signals. So the most important signal that OpenTelemetry started with was tracing or distributed tracing, something that you would use with an application performance monitoring or APM product. Metrics were the next aspect of focus. And then logs will be happening after that as well. There's also talk of adding profiling data or continuous profiling data to these instrumentation libraries too. But the most important thing is it's a single reference implementation per language. I don't need an OTel metrics library and an OTel tracing library and an OTel logs. I can install one OTel instrumentation library per language, and I can emit all the telemetry data that I care about. Also, how it's different is it offers both manual and automatic instrumentation. What do I mean by that? Well, I mean, if you're a software developer, you may have instrumented your app to generate and emit telemetry data. Most commonly, that would be like logs or metrics. Some people do tracing, but that's a little bit harder. So sometimes that's not done today to date. But the other aspect is automatic instrumentation. What if I could just add dependencies or runtime parameters to my app and start it up, and the instrumentation would go ahead and hook into my application and generate the telemetry data on my behalf? OpenTelemetry provides both of these mechanisms, and I'll show an example of it here in just a little bit. And you can use both on the same instance. Maybe you start with automatic instrumentation, and then you later add manual instrumentation to your app. Now, this is all application-based instrumentation, but that's not all that OpenTelemetry focuses on. For example, it supports RUM or real user monitoring. So think of like client-side behavior based on client-side devices. So this could be your web browser, for example, in the case of JavaScript, or it could be mobile devices such as Android and iOS. There are instrumentation libraries in OpenTelemetry for all of this today. And then there's different packaging mechanisms. So maybe your application's cloud native and running on Kubernetes. Maybe it's more traditional and running on VMs or Docker containers. Maybe it's running in serverless and different types of functions that cloud providers provide. In the case of serverless, you need different like wrappers or layers or extensions or whatever the terminology is for the serverless implementation you're using. OpenTelemetry provides this for you as well. The final implementation would be the collector. Again, as I mentioned, think of this kind of like an agent, but it can also be an aggregator or a standalone service in your environment. The agent is actually extremely powerful. It's completely modular in terms of its architecture, and it's completely customizable through YAML configuration. But the basic architecture is that you have a set of receivers. Think of it as a way of getting data into the collector. This can be push or pull based. So for example, for distributed tracing, it's very common that an application will push the spans and traces to the collector. Whereas in the case of metrics, let's say you're using Prometheus, you usually have to scrape your application, scrape the endpoint. That would be a pull-based mechanism. Both are supported by the collector. On the other side, you have exporters. That's how you get data out of the collector. Again, this could be push or pull based depending on the destination you're trying to reach. And in the middle, you have this notion of processors. Basically, what do you want to do with the data once the collector has received it? A great example here would be CRUD metadata operations: create, remove, update, delete. If you want to make changes to the metadata on the telemetry data, then there are processors for that. Now, basically, you stitch this together through what's called a pipeline in the collector, and you can see them as the colored lines in the example here. So for example, maybe I have a pipeline where the orange one, I'm receiving data in OTLP. This is OpenTelemetry's protocol. I'm using a batch processor. Attributes is just the metadata that I was talking about before, and maybe I want to export that data to a Jaeger endpoint. I can do that. You'll notice that I received in one format, but I actually exported in a different. That's the power of the collector. It's actually able to transform the data for you as well. The second example would be the green line. Again, you're receiving OTLP data. This time you're doing batching and filtering, but you'll notice in the green example, it's actually exporting to two different destinations: an OTLP endpoint and a Prometheus endpoint. This is the other power of the collector. You can choose to send data to multiple different destinations, either all of it or a subset of it. You have flexibility and choice depending on your use cases. Pretty cool. And then at the high level, here's the reference architecture. This assumes that you're going all in with OpenTelemetry. So basically, you would add the OTel instrumentation libraries to your applications. You would deploy the collector, typically at least as an agent on each one of your hosts, but maybe as a standalone service as well. And then through configuration, you tell it where to send the data. But this is not a requirement. OpenTelemetry allows you to pick the pieces that you want to use. So let's say my application already has a Jaeger instrumentation library on it or a Prometheus instrumentation library on it. That's fine. You don't have to rip and replace. You can continue using it. You could just point it to the collector and the collector can take advantage of that and send it to your destinations. Or maybe you want to have the OTel library send directly to a backend and you don't want to use the collector at all. That's also fully supported. So you basically have flexibility and choice every step of the way, which is pretty cool. Now, in terms of the project status, the way that OpenTelemetry looks at it is through the different signals. Today, the three primary signals are traces, metrics, and logs. And then there are subcategories for each of them, primarily around the API, the SDK, and the protocol. For tracing and distributed tracing, everything is fully stable today. There are lots of people using this in production environments at scale. It is ready to go, so you can definitely use it. From a metrics perspective, it's most of the way there. We have the API and protocol in a stable format. The SDK depends on the language implementation, whether or not it's stable, but it is maturing very rapidly. And again, lots of people are using this today. And then from a logs perspective, the protocol is stable and the API and SDK are still in draft. But that will move to stable here in the next 6 months or so. It's actively underway. There's a bunch of more information you can read about the OpenTelemetry project. I provided a bunch of links, but I'd actually like to show you a demo and you can take a look at these links afterwards to kind of see how to get involved. OpenTelemetry actually provides a demo application, so you can go on GitHub and you can take a look at it, exactly what I'm about to show you. But I wanted to kind of show you the power of how you can get started and why you might care about this application. So with that, let's move to a demo. All right, so just to show that this is running locally on my system here, you can see that I have log messages coming in. This is actually a live demo. So if you actually were to download and fire up the demo application that OpenTelemetry provides, it's actually a web store that you can interact with. So for example, I can click on these glasses. Maybe I want 2 pairs of them, add it to my cart, fill in all my checkout information, and go ahead and place that service. And this is actually happening live in the backend. The backend's actually made up of a distributed microservices backend, and it's polyglot in nature, meaning that the different microservices are written in different languages, but they're communicating with one another. The demo is also hooked up with OpenTelemetry instrumentation and the collector. So you can actually see trace information, metrics, and logs that are being generated as a result of interacting with this web store. And I can actually show you that live because the demo also has different backends configured. For example, if you're familiar with Jaeger, this is the Jaeger backend, which supports distributed tracing. It is another open source CNCF project that you can actually try out. And for example, the interactions I was making, like checking out my cart, you can actually see like there's a checkout service here, and there's a bunch of metadata associated with that checkout service. Like, for example, the checkout service is instrumented with OpenTelemetry. It's actually a Go or Golang based microservice. It's running on a Linux device. And I can actually see that it was making REST or HTTP calls that were successful to the email service. So a lot of rich metadata here that I can actually use to solve both availability and performance problems within my environment. And this is all kind of provided out of the box, which is really, really cool. I also have a Prometheus instance up, and you can see that it's actually talking to the OpenTelemetry collector and getting the metrics data. And if I were to actually search, like maybe I want to search for OpenTelemetry metrics, I can pull up any of the metrics that OpenTelemetry is emitting, and I can see that data. Of course, I could hook Prometheus up to a Grafana instance and visualize that as well. But this helps me do 2 things. 1, I can see the health and performance of my OpenTelemetry collector, but 2, I can also see all the metrics that are flowing through it from my different applications in my environment. And then finally, I have an Elastic instance up because this demo application generates logs as well. And in this case, for example, I'm looking at the add service, which is another microservice in this environment. You can see it's also running on a Linux device. I hope so. It's running locally on my system. I can see things like severity, so like syslog type nomenclature that you might be familiar with, and even the log messages that are being generated. Now, what might stand out to you is that regardless of the data source, I have context and correlation. I have the resource and infrastructure information available to me. This is the power of OpenTelemetry and the power of the specification that I was showing you earlier. So regardless of which backend you're using or which signal you're looking at, you can actually solve a whole bunch of availability and performance issues and jump between different data sources as you see fit. Now, I would like to show you this live too. So let me just switch over to my terminal and show you how this kind of works if you were to kind of download it and install it. So basically, it's a Docker Compose file, and every single one of the instances that I was showing you is its own container. So like I have an Elasticsearch, I have a Jaeger, I have Prometheus, but I also have the applications in here as well. So for example, you'll see the ad service that I was showing you earlier, or the checkout service is in here as well. So everything is completely decoupled. And all of these apps have actually been instrumented with OpenTelemetry. Let's take a quick look at that. For example, if I go to the ad service, this is a Java-based application. And if I actually go look at one of the Java classes here, so I'll get the ad service, what you'll notice, like, for example, look at the imports, nothing is importing OpenTelemetry. And yet this Java instance is actually emitting trace data. It's emitting telemetry. How is that possible? And the answer is automatic instrumentation that I was telling you about before. So for example, if I look at the build Gradle here, what you'll see is it's actually importing through Java options, the Java agent with the OpenTelemetry jar file. So basically, all I did was add a dependency to my application before I started it up. And then within my Docker container here, I just added some environmental variables. So I basically said, hey, I want to give this thing a name. So the service name will be the ad service. And I want to use the OTLP endpoint. That's it. I made like 3 minor configuration changes and I started my Java application and I immediately get telemetry data. That's the power of OpenTelemetry. And it's of course language specific. So for example, if I take a look at another service, maybe I'll look at the currency service. This is actually a JavaScript application. This just has a little bit of boilerplate in the terms of a tracing.js file that I import that has all the OpenTelemetry nomenclature in it. And then all I need to do is, again, tell it how to start this. So in the Docker file, you'll see at the bottom here, I'm just adding that tracing.js file, and I immediately get instrumentation. Again, simple and easy to get started with OpenTelemetry. One final example, let's look at the email service. So the email service is actually written in Ruby. And the reason why I want to show you this is because this has both manual and automatic instrumentation. So you can see it actually requires OpenTelemetry, something that you didn't see in Java. Here's where the automatic configuration comes in. For example, this is using Sinatra, and there's automatic instrumentation for that. But at the bottom here, in one of the functions, the send email function, and a manual span is being created called send email. And attributes are being added to it. Think of metadata. So like email sent true is being tagged on to that span. So here I have both manual and automatic instrumentation in OpenTelemetry being used, and all of that data is being sent through the collector. The one final thing to show is actually the collector itself. And as I mentioned, it's made up of receivers. You see them at the top, processors, what I want to do with the data, and then exporters, how I want to get the data out of the system. You can see that I was using Elasticsearch and Jaeger. Here's where they're actually defined within the YAML configuration of the collector. And then all I have to do is basically define pipelines, like receive trace data over OTLP, do some batching, resource and resource detection type processing, and then export that data to Jaeger, and I'm good to go. If I want to send it to a second destination, I can just tack it onto this list and I'm all set. So kind of flexibility and choice every step of the way. And that kind of wraps up the demo. So as you can see, OpenTelemetry, very powerful, very cool project, open source and vendor agnostic, really making your life easier from an observability standpoint. Be sure to take a look at it, and I hope you enjoyed the talk. Thanks so much.